Welcome back. As usual, I keep telling you to subscribe my videos. I'm going to cover the whole of mechanics and heat in the entire series. That should be useful to the people who are preparing for the entrance examinations in engineering and medicine. And then, in addition to this, is going to be very useful for all those engineering students who are looking at the kinematics part of it or the mechanics part of it. It's going to be very, very useful. Now, continuing my discussion in my previous lecture, I'm now going to look at radius of curvature, whenever a particle is, if it is circular motion, there is no problem. Directly you will say that. Now, but one important thing that one should understand in circular motion, before I go to the radius of curvature, the people generally call uniform circular motion. What is uniform circular motion? Angular acceleration is zero. This is what you have to keep in mind. Angular acceleration is zero, it's called. Now, in uniform circular motion, of course, your AR is always omega cross R. Or if I write the magnitude of it, omega square R. That's how you're going to get. Now, in uniform circular motion, what are all the things that are constant? I'll give parameters that are constant and that are variable, because this is one point which I forgot to mention in my previous lectures, because most of the people do wrong in this. Now, what is constant? Of course, alpha is constant. Alpha is not a variable here. What is constant here is omega. Alpha bar is 0 and omega bar is constant. It doesn't change its direction or magnitude, right? What is variable? V bar is a variable, remember. What is constant here is mod V is constant. Mod V is constant, but V bar is a variable because it has every instant it changes the direction. What is constant? R. This is what is variable? R bar. That's a variable. Okay. Now, very important, people think that this is a constant, but no. Even AR, but because it has a direction, at every instant, it is directed towards the center. Look at the direction of these is completely different. Incessantly the direction changes. Therefore, AR bar modulus is undoubtedly a constant. But what is variable is AR bar. But understand, velocity is a variable, R bar is a variable, AR bar is a variable. One good thing here is AT is 0 and question of variable doesn't arise here because mod V is constant. Now this is a very important point. Based on these things, sometimes they ask you, what are all the perpendicular parameters? Now I'll give you that also for you. First I gave you constant and variable in UCM. Okay? Now, in circular motion in general, what are all the things that are perpendicular to each other? The combinations I will give you one by one. R bar is perpendicular to V bar, AT bar. That is because all tangential parts are bound to be perpendicular to R bar. Okay? And next, R bar is parallel to A R bar. Maybe anti-parallel. Actually negative, it is oppositely directed, remember. So, perpendicular means what? R bar dot V bar 0, R bar dot AT bar 0. This is always true. Instantaneous, always true, you can take it. That's one. Next thing is AR bar is perpendicular to 1 V bar AT bar. Right? Now, while writing this, I have written like this, but R bar is, these are all in the plane. Therefore, this is perpendicular to theta, perpendicular to omega, perpendicular to alpha. So, in a similar way, here, theta, omega, because these are all perpendicular to the plane itself. Therefore, these parameters are bound to be perpendicular. Alright? So, you have got like this, AR is perpendicular to all these things, and therefore, the dot product of this with any of these things is bound to be 0. That's number 1. Number 2. Now, go a bit further. A bar you have seen now. If I write AT bar, now this is perpendicular to 1 R bar to AR bar, theta bar, omega bar, alpha. Remember, everywhere, even if I do not mention, one has to do that. That's very important. Okay? So, whenever I am using the perpendicularity, the cross product of these things is bound to be 0. That's how you have to understand this. And as far as the parallel are concerned, now I am giving you here R bar, AR bar you have given, and then V bar is parallel to AT bar, because all are tangential. Now, theta bar may be parallel or anti-parallel to omega bar alpha. In a similar way, omega bar is theta bar alpha. Alpha bar is parallel. Wherever you have these parallel components, cross product must be 0. So wherever perpendicular, all the dot products, if you see on this side to the other side, that is bound to be 0. I hope these are all clear to you. These are all very, very fundamental. Don't get confused when they ask you. I told you in the very, very beginning, if you understand vectors, half of physics is in your blood. And if you are exceptionally good at calculus, another 25% there, minimum remaining 25% is the actual physics that you have to try to relate it with these things. Now, see, whenever you want to get radius of curvature, the radial acceleration, you take the magnitudes omega square r or v square by r. Sometimes this is called normal acceleration because it's perpendicular to the tangent, okay? But it is always directed towards the center. Wherever you come across, you have to look at this way only. Say, for example, we have already looked at the parabolic case. This is a projectile, you know that. Now suppose if I project it with you at an angle theta, see, at this instant, every instant in a parabola, the radius of curvature keeps on varying. It's not a standard circle where the magnitude is constant. Although it is variable in direction, magnitude is also variable here in this case, you could see. So what you should see here, see, you want to get radius of curvature. R is equal to V square by AR bar. That's how you have to take. What is the acceleration here? Acceleration is G. And now this is your work. What is the component of all this? You could see this is theta. Therefore, this is G cos theta. So the radius of curvature at O, I will call it as P. R at O, point of projection is U square by G cos theta, where theta is the angle of projection with the horizontal. Right? Now, let me, at this instant, suppose if I am taking at the topmost point, you know what is this? U cos theta, because the vertical component is 0 there. And you know very well acceleration is like this. So if I say, I will call it as point B, this is point C, or at the highest point is U cos theta whole square by G. See how greatly they are differing. Now let us generalize this. What do you mean by generalization? You should be in a position to get anything and everything. Let this be B, and you know, let this angle be alpha. We are not sure what is that angle. And this is G. How to write this? I'll tell you. First of all, this one. This angle is alpha. Therefore, this is. So, very easily, I can write V square by G cos alpha. You don't know what is alpha, you have to find out. But do you know one thing? You recall, a V bar is IU cos theta plus J after time t, or P you can say RT at any time t. What is the radius of curvature? Now how do you get alpha? You know that tan alpha is equal to U sin theta minus dt by U cos theta. From this you can get cos alpha. That is one way to work out. Okay. Another way is, you know that this is always U cos theta. Horizontal component will not change. How do I write V? If I do like this, so V mod V is equal to U, I'd say V cos alpha is U cos theta, or cos alpha is U cos theta by V. I can make use of it here. There's so many ways of writing it. How do I write that? V square by U cos theta by V means another V, that is V cube by U cos theta. V is velocity at any instant, total velocity. This is another way to write. How to get total velocity? You know that. How do U square cos square theta plus U sin theta minus dt whole square under root 3 by 2 by U cos theta. This is our radius at any time t. Now you can take that time factor and then substitute it. All answers that you got before, you are going to get it right. Okay? Right. Now, make use of it for any of the purposes that you have and work out, you will get that answer. Right? So radius, they may ask you in some occasions, what is this value, etc. I think you may try to give that. Fine. Now I'm coming to the final phase of kinematics. We do look at projectiles on inclines or inclined surfaces. So what do? I take one inclined surface, I project it with you. Originally, we used to take this angle with horizontal is theta. We continue to do that. But the angle with the inclined surface is alpha. I am talking of upward projection. So, theta is nothing but alpha plus beta. Now, how does this go? This is how it goes. Now, you see, I take it as I take it as J. Now, immediately, whenever such things are given, I already told you to write down in vector notation. Now, you know the Ukasic, right? This is G, vertically down, and if I resolve the components, along this is U cos alpha, along J, it is U sin alpha, isn't it? U cos alpha, U sin. Now G, what is this? This direction is minus sign. This direction is minus. If this is beta, these two are perpendicular, this is bound to be beta. So, this is G cos beta and this is... Now, I want each one of you to follow this notation. I made you write several times if you go through my previous lectures. Whenever a projectile problem is given, first of all identify your ij. Feel free to take any ij of your choice. It should be easy for you to handle it later on, and then afterwards you can interpret it appropriately. So I took I along the incline, J perpendicular to the incline, J is no longer vertical here, I is no longer horizontal here. The whole thing becomes your original symmetric oblique projectile provided beta is 0. Every time we derive something, you may probably interpret it to that so that you will get your answers appropriately. But first of all, let me write down. Now, this is a crucial step for you. IU cos alpha plus JU sin alpha. A bar. What is A bar? Now look. This is minus I component G sin beta. Therefore, minus I G sin beta minus J G cos beta, because this is G cos beta. Now, once you have velocity and acceleration at your disposal, I made you write all those things, and now immediately you can probably do with this Vt bar that's equal to I. Now, U cos alpha minus Gt sin beta plus J U sin alpha minus Gt cos beta. U plus Gt form because these are all constant acceleration components. Oh, now with this, yes, the displacement part of it along I, ut plus half at square. Now same thing, ut look, once I write these two, you can automatically write the remaining. Now V at any x, y, what is x? This is my x. Perpendicular is my y. Therefore, what do I do here? Vxy I under root u square 2as minus 2gx sin beta. You see, for s I am using x because along I it is x. But along j it should be y. Therefore, how do I write it? U square sin square alpha 2g by cos beta. I've just written down those equations. I don't think you should have any problem in just writing this part of it. Now the next part is your interpretation, of course. Now if I want to know what is the time of flight of this, now you look, this and this. So y is 0, this is the time of flight. So I would say A, B. Now the projection here is C. The projection there is C. Now AB, what is AB actually? I will write it here. AB is range on the inclined surface. Time taken from AB is time of flight. Okay? Now, with this, we will try to find what is the time of flight, for example. Y 0, therefore this should be 0. If I equate this as 0, one is t is 0, the other is 2u sin alpha by, what are you getting? G cos beta. Very simple, t goes off, 2u sin alpha by g cos beta. This is the time of flight of this on the inclined surface. You got it? Now we have to find out what is a range, etc. I'll tell you. Meantime, I will remove this diagram. I can draw this at any stage if at all we need it. Alright? Now, we got the time of flight also. Now, I want to know what is the range. If that is the case, what should I do? When t is equal to capital Dx is equal to Ri. Is it? So this is x. So what do I do? Ri is u t cos alpha, isn't it? Minus half g t square. Why am I getting beta here? Sin beta. Okay. That's how we got it. Now I'll substitute for t. T first I'll take common. Now if I substitute here u cos alpha minus half g sin beta t. T is 2u sin alpha by g cos beta. From here I have directly substituted. G gets cancelled, 2 gets cancelled. This day I will substitute it later on. There is one u here, there is another u, I remove it, and then this becomes cos alpha, cos beta minus sin alpha, sin beta by cos beta. You know very well, all this is cos of alpha. And now t you can substitute 2u sin alpha by g cos beta. Now what am I getting? Cos of alpha plus beta. Okay? Now, it all depends on in which one do you want it. You can do that. Now I further try to simplify this. I'll write it here. Here is a 2 sin A cos B. 2 sin A cos B. Sin of A plus B plus sin of A minus B alpha minus alpha minus beta. The two sign, now the remaining is u square by g cos square beta. Now this is sine of minus beta is minus sine beta. So u square by g cos square beta sine of 2 alpha plus beta minus sine beta. This is the range expression on this. Okay, it may appear little complicated, but if you write these equations, everything becomes simple. Don't try to memorize this. In fact, I want you to know how to write this, how to get time of flight, how to get range, everything you can get from this, all right? Right. Now, this is range when you project the body up the incline. So you have got this now? Put beta 0, what do you get? Suppose if I put beta 0, this goes off, this becomes sine 2 alpha, this becomes 1 u square sine 2 theta by g. That is your original range expression. Okay? Now, we will, I'll try to erase this. Anytime I want, I can write it down. This is now. What is the maximum value? When do you get this maximum? When this is maximum. Got this? When this is maximum. When beta, you can't do anything. So this should be maximum. That means 2 alpha plus beta must be, the sine 90 is 1. So this is the relation. So 2 alpha is pi by 2 minus beta. Alpha is, this is for R max. So this becomes 1 minus sine beta u square by g. But what is this? Cos square is 1 minus sine square beta. You can write a plus b into a minus b form. A minus b gets cancelled. Now that leaves you with u square by g. This is the R max. Or you project it up the incline. This is what you're going to get. Now, as I said, if you put beta 0, you will automatically get this maximum range as u squared by g. Let me tell you another interesting fact. I'll erase this part everywhere, okay? Except this now. R max up the incline is u squared by g into plus sine beta, and alpha must be right. All right? Now, I have written all this everywhere. Now, look at that. Supposing if I project like this is alpha. So let me presume likewise it has come. This is my horizontal line. Therefore, this is theta, this is beta. So how do you write? Alpha is equal to theta plus beta. Theta is alpha. Or I'll write it as theta is alpha plus of minus beta. You know why I wrote this? It's simple. You need not have to work on anything at this stage. Wherever you get plus beta, you replace it with minus beta. You will get everything pertaining to down the incline, including your time of flight. Time of flight makes no difference because it is cos beta. So beta, whether it is plus or minus, it makes no difference. You get it. But what about R down the incline, or du, down, or down the incline, di, I write u square by, here it makes no difference, cos square beta. This is minus sine 2 alpha minus beta, minus of minus plus. So that's how you have to look at the difference between the two. Okay? Now, R max down the incline. Now, this is, you already got it, this becomes minus. And this becomes alpha must be pi by 4 plus 2. Let's see how interesting it is. It's very simple, straightforward, nothing to worry. Take down those expressions, write one after another, and first get time of flight, then you get a range of the projectile on the inclined surface, up the incline, down the incline, both we have got it here. I hope it's clear to you now. Now, with this background, anyway, I just give you a couple of examples. Say, up the incline, I may ask you, if this is beta, what is the condition for the projectile to strike it perpendicular? It should come. That means I am drawing the reverse back. What do you mean by this? What do you mean by it should be striking perpendicular? That means its parallel component must be 0. And parallel component of velocity must be 0. The x component of velocity must be 0. If we took it as I component of velocity must be 0. All mean 1 and this. Now go through that. What is that x component of velocity you got? Shall I write that here? First of all, v at any time d, I u cos alpha minus gt sin beta plus j, etc. I want this to be 0, x component. Therefore, t is equal to u cos alpha by g sin beta. Alright? But this is nothing but, now whenever they ask questions, look at the concept. What is it I am trying to do? He is asking some condition. Whenever he is asking condition, you try to obtain one parameter in two ways. For example, I am looking at the time. I got the time in one sense using the condition. The second one is, you get the time by different means because it is nothing but your time of flight. Time of flight, you have a general expression, you already derived that. 2u sin alpha by g cos beta. These two must be there. That is your condition. It's as simple as that. So now equate these two. What do you get? This is equal to 2u sin alpha by g cos beta. Now you make necessary changes. Cos alpha cos beta is 2 sin alpha sin beta, or if I take on to the other side, 2 tan alpha tan beta is 1. You want, you can write in terms of theta also, no issue. Likewise you get. Okay? Now, I'll give you another example. Another example is, what is the condition for the particle to strike it horizontally? Horizontal means if this were not to be there, that's how it should have come. Okay? Now, what is the gain? Time taken is t. This time taken is nothing but, if this were to be your original projectile, it is nothing but time of ascent. So the time of ascent is nothing but u sin theta by g, and this is nothing but your time of flight. So equate these two. U by G at again gets cancelled. Sin theta is, sin theta cos beta is equal to sin alpha, but alpha is theta minus beta. You know, theta is equal to alpha plus beta. So sin theta minus, I can write it as 2 sin. So if I sin A cos B minus cos A sin B. Sin theta cos beta, sin theta cos beta. So you bring this on to this side, it becomes 1. So this will be 2 cos theta sin beta is equal to sin theta cos beta. Now I take it here, I bring it here. So the answer is 2 tan beta is tan theta. This is how you are going to work with this kind of problems. You know, whichever they ask in this, actually this is not there in the syllabus, but I think you should know how these are, because even in relative velocity we try to do this. Even in relative velocity. So that is the point. So I tried to give you a few examples of this. There could be something, but if there is a specific request from anyone, additional things also I can do it, but I'll be shifting from now on to the dynamics. This is the last of my series of lectures in kinematics, including circular motion, projectile motion, etc. Okay? So thank you very much for this.